Hi folks, today we're going to be covering radicals, aka roots, specifically square roots. So if I have a number like this inside a radical, square root, basically this is asking the question, what times itself equals 9? So in other words, what times itself equals 9? And we're going to stick with positive numbers when it's written this way. So the answer in this case is 3. The radical itself is designed to basically cancel out a square. And so the way that we're going to actually, so I'll get back to this, but the way we're going to start with is basically, if I have a number inside a radical, I need to figure out what times itself equals that number inside. Now, at this stage, you're going to be sticking with perfect squares. So 1 times itself is 1, 2 times itself is 4, 3 times itself is 9. These are going to be the common numbers that you're going to be dealing with. Hopefully you know your times tables up to 12. That'll be handy to keep in mind. So 11 times 11 is 121, 12 times 12 is 144. The ambitious of you can go up to 15 or 20 or whatever you want, but I would say definitely up to 12 is going to be useful because it's helpful to know that that is equal to 12. You can break up these numbers into prime factors if you needed to simplify it, but that's a little bit more of an advanced topic. For now, all of these will be perfect squares. They may also be fractions. So if I have square root of 4/9, the way to think about this is still what times itself equals 4/9, but to streamline it, these radicals can apply to each part of a fraction. As long as you have multiplication or division inside, it can apply to each piece separately. So if it were multiplication, if I had 4 times 36 here, I simplify that as square root of 4 times square root of 36 and evaluate each of these square roots. Square root of 4 is 2, square root of 36 is 6, 2 times 6 is 12. Going back to the square root of 4/9, I can apply that square root to each piece and then simplify each piece. Square root of 4 is 2, square root of 9 is 3. You have a slightly more complicated fraction problem that involves a decimal. The way to think about how to simplify a decimal, again at this level of problem, is in order to, what do I have to multiply by, what power of 10 do I have to multiply by to get rid of the decimals? So I have to multiply by, so in order to move it 2 decimal places, I have to multiply by 100. But if I just multiply by 100, I'm changing the problem. I'm changing the number. I'm allowed to multiply by 1, and I'm not changing the number. So what I do is I multiply and divide by 100, do the multiplication part, and I've converted this decimal into a fraction. Then what I do is I apply the square root to each piece, just like I did up here. Square root of 144 is 12, because 12 times 12 is 144. Square root of 100 is 10. And remember, I'm not quite done. I am quite dumb. Because these are both even numbers, and so I can divide the top number and the bottom number by 2. 12 divided by 2 is 6, 10 divided by 2 is 5, so that's 6/5.